we are now about to deep dive into the world with generative AI. So that's going to be the entire focus for our upcoming session. So let's shape the world that we live in with generative AI. So to take us through, I'm going to quickly invite back on stage Praveen MYSORE, Industry Consultant Director, Dassault Systems, India. Can we have a round of applause, ladies and gentlemen? Let's hear it for Praveen MYSORE.
That was an interesting session and the discussion with Mr. Karthik Narayan. And now we take you to the generative artificial intelligence topic, which is the topic which is an in thing today as we all see the world. With the advent of ChatGPT, all of us have come to know about the power of artificial intelligence, right? And today, I'll take this opportunity to also give you some visualization of its application in engineering world. We have seen the growing usage of artificial intelligence in media world, e-commerce world, life science space, etc. What I am trying to do is I'm picking 3 spheres of economy, that is manufacturing world, the infrastructure, and life science space. And let's try and see an example from each, okay? How Dassault Systems is contributing to generative artificial intelligence in these domains.
Generative design and topology optimization are advanced design techniques to quickly create and evaluate alternative designs based on functional requirements, such as material, desired weight, performances, and manufacturing processes. Generative design uses non-parametric techniques, such as topology, shape or bead optimization, and leveraging finite element analysis to calculate stresses, strains, and displacement based on your inputs. User variables are passed through an iterative optimization loop to come up with the most efficient design to answer the functional requirements. One of the most common techniques in generative design is topology optimization, which identifies the optimal material distribution to achieve a given objective, such as maximize stiffness, while taking into account the different loads, restraints, and constraints defined over a design space. Topology optimization produces components that are significantly lighter and can achieve better performance while adhering to strength and geometry requirements. By stripping away void elements, topology can also produce unexpected new solutions to design problems. Calculations that would take months to do by hand are done in a matter of minutes. And because 3D Experience CATIA is based in the cloud, you won't need vast computing power to run the calculations. Nor will you need to understand advanced engineering methods. CATIA's function-driven generative designer's intuitive interface allows designers without expert knowledge to set up and run generative design cycles themselves.
So same way, we'll see another example from infrastructure industry.
3D Experience R 2023X introduces Visual Script Designer, a new role to serve multiple industries and disciplines, such as creative design and styling, mechanical engineering, architecture and construction, and many more. CATIA Visual Scripting is a new native application to generate parametric geometries with a visual programming language. All design operations are represented by graph nodes, and relations between nodes are directly editable. Complex and intelligent designs are now accessible without any line of code. And any algorithm can then be captured as a new shareable operator and reused to speed up next design projects. It's also a good way to share and reapply best practices across your team. Another benefit of the parametric and algorithmic approach is design exploration. Generate a lot of design variants or alternatives in few minutes, just by changing parameters values. And select the best design, according to specific criteria or indicators. CATIA visual scripting can be enriched by additional operators to address more complex and advanced use cases, depending on additional roles and applications. For example, some additional operators are dedicated to mesh modeling. It's an easy way to rapidly create organic shapes from mesh subdivision and smoothing. It's even possible to generate a subdivision surface from mesh, which is fully re-editable in other CATIA applications, such as Creative Design Experience or Imagine and Shape, available in additional roles.
So we could see the application in the design space. At the same side, we also look at the therapeutic design in life science domain, where the repetitive task can be automated clearly, as you saw in the earlier two examples also. Can we play the video, please? Yeah. So you can see here how a model can be evolved for a given molecule based on various criteria, and then how you can run the optimization for various targets that you may set for optimizing the design. And then the system will go and then evaluate various iterations and then throw you the results for you to choose from actually. So this kind of automation is highly appreciated in life science domain, because doing this humanly is next to impossible. Hence, this is actually crunching your time by quickly iterating multiple scenarios based on the objectives or the targets that you may have set, and then throw you all the results accordingly. So these are varied application domains that you have seen where artificial intelligence can be applied readily. And of course, we would have another round of discussion sometime later on the artificial intelligence based on data science experience. Here I just wanted to focus primarily on the engineering domain. Followed by this, I also would want to invite Mr. Prasad TARE from Tata Motors, who is leader at engineering IT in Tata Motors, who has led many automation projects, and I'll be happy to have him share his experience in this session.
Yeah, thanks, Praveen. Very good afternoon to all of you. And at Tata Motors, we are using 3D Experience platform and various CAD softwares from Dassault. As technology is progressing, over a period of time, the expectation from CAD softwares are increasing. And there is an exponential increase in the expectations. See, the expectation of people, 20 years back, few decades back, if you go back, you will realize a CAD software was expected to play a role of CAD, plain CAD, with a basic feature, that's it. But now, something more beyond is expected out of it. And that's where the automation is coming into picture. In our case, automobile engineering, the vehicles, the cars, few decades back were playing a role of a car. Then it got converted into car plus music system. Further, people expect it to play a role of cell phone as well. Now people want it to play a role of computer, and going forward, people want autonomous car without driver. Probably they would require autonomous car without passengers as well. So who knows? And the case has come where a delivery, Amazon delivery is being done through drone. So it is a autonomous car without passengers. So the point here is, over a period of time, expectation from the products are increasing. That's where these software companies like Dassault and other companies, they are introducing new products, new features, new functionalities. Now the question is, as a customer, are we really benefiting those or leveraging those completely. And to answer it positively, what you need is a customization which Praveen spoke about. You need to customize softwares, okay, at various stages and various levels to get the fullest benefit out of it. Otherwise, you may not be leveraging complete out of it. Now here, I am going to present one case. Okay, maybe a next slide. Oh, is it here with me? Okay, so customizations are of two types. One is an interface customization, meaning you want your software to interface beyond the limits. Software is not just not a software. You want to have a digital continuity. We speak about digital continuity. We speak about digital thread cutting across various domains, end-to-end connectivity. Now, to achieve that, what we need as an industry is an interface to the software. So interface software, I'll give one example which is beyond your own industry. For example, e-commerce industry getting interfaced with the banking industry, and you get seamless shopping experience on your mobile. Banking is a complete different sector. E-commerce is a different sector, but you do purchases in 2 seconds, just few clicks, and it starts for the delivery. So this is what I am expecting when I say interface. So same interfaces are required within the organization, okay, so that you cut across various domains, various workflows, even some of your web-based applications, and that's where these interfaces come into picture, so that any software fits into the totality as an interface. Now, recently we interfaced 3D experience platform altogether so that it communicates with our existing ecosystem, various CAD systems, and even web systems. So probably we are the first to integrate it in this manner so that it fits rightly and it ensures digital continuity end to end. So that is one of the use cases I was talking about. Second interfaces or second aspect of the interface is a 4-layer within the software. So you need to customize the software within, not interface. So within, there are 4 layers. The first layer, of course, there is a base CATIA layer or CATIA 3D experience layer in our case, but you have to have 4 layers. The first layer is a slightly superficial layer, okay, which talks about basic design qualities, which talks about, bare minimum checks of the quality. Going forward, it becomes the second layer where you build your own application on top of it. In our case, for example, we have built a Viper application. Okay, now Viper application, it ensures rules and regulations, okay, which gets covered, which gets adjusted, which gets optimized in the design itself. So this is the most important aspect. If you do this, you will save a lot of time of your end users, and thereby productivity will go up. Time to market and quality, these are the 2 buzzwords apart from the digital continuity. So the second aspect gets covered in this. So you have to have your own applications which automates the thing for you. The third layer is talking about design application. You can do design itself using those applications. Now in our case, we have our own welding application built on top of 3D experience platform, which leverages the benefit of 3D experience, but also takes care of our internal rules and regulations. So it is called altogether a design application. And the fourth layer, which we spoke about just a while before, which is generative AI-based layer. We have our own generative AI application portfolio, which talks to this 3D experience platform, and thereby it gives a complete benefit to end user in reducing the time and quality, in improving the quality. So with these aspects which are going to cover in coming days, okay, in our case, we have our own app store. Okay. We have built so many applications on top of CATIA that we have our own app store, like a Google Play Store, and we give user a variety of applications which can reduce their time and improve the quality. So these are certain examples we cover upon. We have BIW design, we have styling of a car, We have analysis on top of it. We have electricals, because again, electric vehicle is another aspect which is coming up. And lastly, we have tooling and die design. Similar portfolio is also available for our manufacturing portion, which sits on top of Delmia applications. So I'll quickly run a small video. Not running. Can you run the video inside this, which gives a glimpse of the application store that we have built? Okay, so this is our own application app store I am talking about. It pulls many applications which are at superficial level, okay, which goes and does some basic quality checks, like part numbering scheme, and the various templates are pulled internally, and thereby we get a full utilization of this part numbering system of ours, so that user does not make any mistake out of it. So second one, if you look at is for material application. It applies materials automatically based on certain questions, and thereby saves the time for our designers. And lastly, it is a design application. Okay, we are doing 3D welding, okay, automatically on top of the panels shared to the designers with certain rules and regulations. So we have our own guidelines or IP. Our own design IP gets integrated with this Dassault tools, and then it makes an application out of it. So this 3D welding, or if there is arc welding, okay, there are types of welding and the applications are there. So this helps in total as a productivity, and also it helps, to reduce the total time to market. So this is arc welding example, and this is a material thickness example. So that yellow portion is designed automatically by our application. So with that, thank you to all of you for enjoying this session. Thank you, Praveen and DS team as well.
Thank you very much, Mr. Prasad, and thank you very much, Praveen.